Hey, welcome back to Mechanical Pros. I'm here with my man Jeff. Today we got a great one for you. We're talking about controlling fire systems with the ABB ACH580 and how to control basically the supply side of air for building pressurization and how to do that with your VFD.
Absolutely, John. A lot of what we do is, most of you guys are used to seeing variable frequency drives on air handler units, RTUs, that type of stuff. But how they integrate into a fire alarm system is completely different. The devices are not UL864, so it has to be controlled by a UL864 contractor, which is generally your fire alarm contractor. Now, AHUs and RTUs and that type of device, they serve dual purpose. They also supply cooling to a building and everything else. But in the event of an emergency, fire alarm comes in, air handler supply has to be shut down, and it's a hard shutdown. That means there's a wire that does not allow the connection to go to the motor. And then you have the return fan and the exhaust system that we'll talk about here in a minute.
Okay.
But the supply fan, it will get a hard shutdown because we don't want to feed a fire.
Yeah, so we're focused on the supply side.
We're focused on the supply side right now.
And then what about the exhaust side?
Now the exhaust side, what happens is the fire alarm takes control of the dampers in the building. They'll open the smoke dampers and they'll close outside air. Now what happens is the return fans will operate at a preset speed, because remember, building automation has to be considered out of the loop right now. We have no speed control. We have
run independently.
Yeah, it may be gone.
Right.
So we have to control according to what test and balance tells us gets us enough pressure in that duct to force smoke out of the building.
Yeah.
Return fan turns on, exhaust fan turns on, and it evacuates smoke. Usually it's a supervisory control. That's usually something the fire department does when they show up.
Yeah, gotcha. So at what size building do we need to start worrying about this?
You know, stairwell pressurization will occur in any building, but to be monitored and to work the way it's supposed to now, 9 floors and above is what code says.
Okay. All right, show me what we got here.
Well, what we've got is right now, remember that the drive itself has to be considered a third-party device. I cannot control smoke dampers. I can't move any other mechanical device other than the exhaust fan or the pressurization fan. So what we have is I have this set up right now in what we call PID loop. And when we get on the whiteboard in a second, John, I'll show you how that all interacts. But basically what happens is the building automation system is completely gone. These fans that are on stairwell pressurization and elevator pressurization, they only run when there's an event. They don't run any other time, okay? And when I get the event input from the fire department, they'll give me a contact closure and I will go ahead and I'll get a run permissive. That means they have opened the smoke damper and now they're giving me a run permissive. Now they're gonna send me the run command and I have the run command. This is my run permissive here. If I lose my run permissive, the system will shut off.
Okay, that call is going to come from the fire system, not the building automation system.
Building automation has to be considered that it caught on fire and melted down. It no longer exists.
I just want to make that really clear.
Yep, and so right now I get the input from the damper in switch on the smoke exhaust fan. Generally there's a transducer that's in there, and the transducer is feeding back what the pressure actually is. Now remember, when test and balance comes in, they measure how much air that they require to get 30 pounds of pull on the door, and they know that 3.5 pounds is going to maintain 30 pounds, and that's why we put a weighted damper at the top of the stairwell that if we get to 3.5, it goes ahead and blows open.
Gotcha.
And now remember, guys, what we're trying to make sure that we do is we don't want smoke to invade on the stairwells because that's your evacuation point. So those doors are going to be opening and closing quite a bit. And if there's smoke on the floor, if you open the door and there's not more pressure in the stairwell, smoke will go ahead and come in, and then it's just like being on the floor.
Yeah, it turns into a chimney.
Yeah, it turns into a big chimney.
Gotcha.
Okay, so we have pressure transducers in there, and we have a set point. And so right now, just for conversation point, I have a set point of 9.7 inches of water column, extremely high for stairwell pressurization, but I wanted it to be there so we can demonstrate and you can see bigger numbers. Okay, so I'm at 9.7. Now this is my feedback coming to me. Now as I begin to lower my feedback, you'll notice my output frequency begins to speed up. As I approach back, now I'm pressurizing the stairwell. As I approach back and get closer to my 9.07, my fan begins to slow down. It'll speed up, it'll slow down. And what this is kind of doing is it's mimicking what happens when you open the door in a stairwell. Because as you open a door, we lose pressure. And so the fan has to speed up to keep the same pressure in there. So that's what we're doing with this right here. And like I said, all doors closed, everything's good. We know that we're going to stay at our stairwell pressure.
But not so much pressure you can't open the door.
Right, 30 pounds of pull is what IBC tells us we have to have. And the Disabilities Act that came around in 2012 has really started to show up in a lot of our specifications that we're seeing in our buildings. And in 2022, we really started seeing them add elevator pressurization. Elevator pressurization is a little bit different.
Same kind of stack effect that you would have.
Same stack effect that we have. We don't want smoke in there because it used to be the old way the fire alarm used to do it. They shut the elevators down, and the only people that could go on the elevators would be the fire department.
Yeah.
But now we have people with disabilities, and you can't get down stairwells. They'd have to be carried. And so there is an evacuation point in a specific elevator that they can go in and go up and down. We have to pressurize that elevator.
Tell me about the over-pressurizing elevator shafts and what that does to the doors.
Well, what happened is elevator doors travel on cables. A lot of people think they travel on rails. They don't. They're attached to cables and they're free moving. And so if we put too much pressure inside the shaft, it forces the door to the outside of the frame and the doors won't open and close.
Yeah.
So it's really important that you pay attention to what test and balance tells you in elevator pressurization.
Yeah. Show me what we got going on here in this diagram.
I wanted to show you, a representation of a 9-floor building. And basically what this is a stairwell. And excuse my artistry, I'm not the best in the world, but this will give us an idea of what the function is. Now, in the old days, back when we used to do stairwell pressurization, it was just based on a single speed. UTAB would come in and they would say, hey, run that fan at 45 hertz. Because what they'll do is they go through and they open all the doors, they check the pressure, they close all the doors, they check the pressure. And we still had, at the top of the stairwell, was the 3.5 inches of water column with weighted damper that would blow out. And so that's kind of what UTAB used to do. When we started getting a little bit more sophisticated and using drives, and remember, drives are, again, John, they're third party. They can't control anything except for the fan, but we can get feedback from UL864 devices. So what we started doing, and this is kind of a representation, the stairwell pressurization fan will always be mounted at the top of the stairwell, and it will generally be ducted out and ducted straight up for exhaust. Now, the smoke damper that is here, very, very, very important that we understand this, is that smoke damper has to be a UL864 device installed by the fire alarm contractor. So that is the damper that we have right here. Now, as we go down, remember what I was telling you, that we had 30 pounds of pull on each one of these doors is all I'm allowed. So what we started doing is not going all the way to the top with the transducer. We would set one transducer about 3/4 of the way up. And in some applications, they say that's enough. But when we get above 9 floors, it's not. So then what we have to do is we have to set another one down here on the bottom. Mm-hmm. We take the one that's 3/4 of the way up. We take the one on the bottom. We average the two. And that's what we use to control the speed, like what we displayed. What I wanted to show you was a little bit the way that this is wired in, because there is no drive, by the way, you guys, in the world that has a UL864 label on it. It's just not something that they find beneficial. So the way that it works is everything is done by the fire alarm contractor, and he will install relays near the device itself, and then he has to control everything. So what happens is fire alarm has to bring the power for this. Now, the reason why fire alarm has to bring the power for this, it very well could be on a generator because the building may lose power. But the fire department still needs to knock down the fire. They still need to get smoke out. It's generally going to be a generated power. Fire alarm brings the supply voltage. They give me a contact closure here, and it begins to open that damper. This is the damper, the smoke damper that we were talking about here. As it moves that damper motor, we move to the variable frequency drive interface. The variable frequency drive interface, the damper in switch is only a permissive. In other words, I'm saying okay, you can run, but wait for fire alarm. Okay, and fire alarm puts in what they call HOAs, like we're used to handoff automatics. We got them on the front of our drives. But what they have is they have two contacts. They want a force on and a force off. So what they do is they bring me down on another relay, a fire alarm on, fire alarm off, and they force both of those per code. And then what happens is once we do that, and I'm allowed to go ahead and start running, I begin to read the feedback back from the transducers, and then I begin to speed up and slow down to maintain the pressure that test and balance has told us we need to maintain.
Gotcha.
This is the only way that you can use a VFD in fire life safety. It can't control that damper, and it can't do anything as far as a run permissive. You can't walk up to it. If you're on the roof and you're looking at it and you say, hey, I want to run this, just check and see if it's okay. When you walk over and you hit hand, it will not run because I do not have a run permissive from fire alarm. So like when we do our installs and we do our startups here at MRG, it's really kind of troublesome because we have to work in coordination with the fire alarm contractor, because if we want to test it and run it or test and balance is there, we have to have fire alarm on site because they have to initiate the run count. Now, I can put jumpers in there and do all that, but that's not a true test of the system, and that's probably not going to fly with the fire marshal.
So it always takes a good bit of coordination, and it's always the last thing that happens on a job.
Right, and it's one of the most important, because as we were talking about, it's fire life safety. So what that means in the event, this is the only point of evacuation. And then, like I said, with the Disabilities Act, as we get on the floors, there could be people in wheelchairs, there could be people that are handicapped in other ways that can't traverse this. And so that is when they initiated, okay, let's give a dedicated elevator that could be operated under a fire condition, and we'll pressurize that, because every time the door would open, we would suck all the smoke in from the floor.
So my point is, if you're building a multi-story high-rise, you're not going to give a certificate of occupancy until you get this thing figured out.
Right.
And usually it's the last thing that's coordinated. So for all you general contractors, mechanical, fire contractors, start talking about this earlier, get it coordinated before the last minute.
So the quicker you get your scope to the mechanical contractor, the quicker that we can go ahead and select the equipment that performs this function. Or, like I said, this is what we see in the state of Tennessee. And remember, local codes will supersede anything. Any city can write a different code around this. But this is the code that we operate here in Nashville and in Middle Tennessee. And again, we have two ways of doing it. Without transducer, UTAB comes in, they tell us, this is the pressure I want, and then we just use the blowout at the top. But the more sophisticated systems, the buildings that are going above 9 floors, this is what you're going to see. There's going to be a feedback device to control that drive.
Yeah.
And that is always supplied by the fire alarm system.
Okay. So if I'm a drive guy and I'm talking to somebody, tell me about what inputs I'm looking for and how I need to tie into the VFD.
Okay, the way that I need to tie in, the fire alarm guy, when I'm talking with him, my first question is, okay, do you have a damper in switch? And if he says yes, then I know that that's going to be my run permissive, not my run command. So I'm going to be looking for on most drives it's safety interlock or whatever. I can send it a run command, but the drive's not going to run. Okay. Then when I get that contact closure, that's a run permissive. That says, okay, go ahead, and when you get that command, you can go ahead and start running. So then I know that the fire alarm contractor is probably going to be using handoff automatic relays that will be wired. It'll be a supervisory control, and it very well could be wired all the way back down to the fire alarm panel, or it could be standalone. And what it is a handoff automatic. He's going to send me a hard contact closure that says, okay, run. And then he sends me another hard contact opening that tells me, hey, stop running. The fire departments come in, they don't want to move, they don't want to pressurize anymore, shut it off. And so they can shut it off without going to the device, because they're not familiar with the building. They don't know where the building's at, you know.
So you have P24 noted here.
Yeah, what that is the low voltage that's generated by the drive. Now, obviously the drives in stairwell pressurization, generally they're going to be a bypass drive. And so I rely on my low voltage control, and I pass that to the fire alarm, and then fire alarm brings it back to me. There are situations where fire alarm wants to bring me the 24 volt. So again, get your scope to your mechanical contractor as soon as possible, because then what we do is we set the drive up for an external voltage coming to it, and we don't have to use the P24, we only use the 3 inputs.
Gotcha.
One other thing that I do want to touch on is that when we get this handoff in some applications where it's stairwell pressurization, or if it's a return fan with exhaust, sometimes what happens is fire alarm with a key switch can come in there and they can turn that switch, and all of these devices will run to destruction. It won't respond to a circuit breaker trip, won't respond to an overload. If we overload the drive, it's not going to trip. It runs to destruction, and that's usually on an election by the fire department on site. The other thing that I wanted to make sure that we covered was the location of these devices. The location of these devices are always going to be on the top floor of a building. If you have a stairwell pressurization fan and it's in the ground floor, probably not per code. Generally, they want these up on top, near the top of the stairwell, because if anybody's going to be running up, they need to be able to get to that. If anybody's running down, most of these exits are building exits. That means once you're out, you can't come back in. Mm-hmm. And so it's very important that you know the location of the devices, and it's very important that fire alarm, mechanical, building automation, that all of those conversations take place long before you hit the job site, because it's harder to work out when everything's in place. If we can talk about it, then it allows us to put our equipment where it's supposed to be, it allows fire alarm to bring the right equipment, and it allows BAS to know, hey, this is when I'm out of it. And just remember, guys, it's very important. Fire life safety is one of the most important things in the building, and just remember, the life you save may be your own or somebody that you know. So it's very important that you pay attention when you're in this business and you talk about stairwell pressurization and you talk about elevator pressurization, that those conversations need to be defined and well defined.
All right, always great to be with you, Jeff.
Thanks, John.
Always learn something. My big takeaway is talk about this early and get it coordinated with whoever's running, providing your VFDs and doing that startup, and talk with your fire system contractor and your mechanical team, and probably your test and balance folks will be involved in this as well.
Absolutely.
So, and the earlier the better. Thanks for checking us out on Mechanical Pros, and we'll catch you next time.